Science 8, it's Mr. Drzezinski. I'm going to do the video that goes along with the exercise for water systems, condensation, infiltration, and stream channels. You'll find this on the Google Classroom. On the condensation step number 1, they ask you to put any amount of ice in a cup and let it sit for 15 minutes. Step number 2 says, did condensation form on the outside of the cup? Well, I have a little condensation here. The ice is melting pretty good. But if I blow on it a little bit with my breath, I can see more condensation form on the side of the cup. Something like that. I don't think there's a lot of humidity in the room right now, and the temperature differentiation isn't enough to get a good drip on the side of the cup. It's cold on the inside, warm on the outside. The ice is going to draw the heat from the room. The water molecules in the room then will slow down and collect together and form droplets on the side of the cup. Condensation. Warm on the outside, cold on the inside. Condensation forms here on the outside. Why does that happen? Condensation, the water molecules in the air, which at the beginning are water vapor, so the molecules are moving fast, but eventually the energy is extracted from them and the water molecules will slow down and collect together into the form of a liquid droplet on the side of the, that's a beaker. Okay, next step on infiltration. I'm going to bend the camera down so you can see the steps. They're going to ask you first to measure 100 grams of sand. I'm going to put the cup on the digital scale. That cup weighs 11 grams. I'm going to take some sand here and pour it in there until I get 111 grams. This sand is very dry. You can see the dust coming from it. $105, $110. Okay, so that'll be that'll be 100 grams of sand. Step number 2, slowly pour 15 milliliters of water. I have 15 milliliters of water in the graduated cylinder, and here it is when you pour it in there. It's not a lot of water. Looks like it started to penetrate down into the sand, percolate. I can see some on the bottom, but I don't see much on the sides. I can see a wetness on the top. What happened to the water? The water sunk into the sand. Step number 4, slowly pour another 15 milliliters of water into the cup. So I have another 15 milliliters of water here. And here it is poured into the cup. That makes a total of 30 milliliters of water. Now I can see the water around the side. I can see it at the bottom. There's still a couple dry pieces of sand at the top. This didn't completely saturate it, I believe. But, well, actually it did. If I tilt the cup around a little bit, I can see some water build up there. I think this thing is holding as much water as it can in the sand. Okay. Does all the water infiltrate the sand? I'm going to say yes. Step number 6, pour the sand and the water into the 5-gallon bucket and clean up. Step number 7, describe saturated. A saturated solution would suggest that you put as much solute in there as it can hold. In saturated sand, in this case, it's held as much water as it can hold, and there's a little left over. The last part of the exercise asks about the stream channel. There are some pictures here at your exercise, and it suggests that the same amount of water is flowing downstream. Which would flow faster? If you take a look at the pictures, the one has a deeper channel, the one has a shallower channel. It's wider. This one's skinnier. Which one would flow faster and why? Okay, see if you can finish that and turn that in. Thank you.